Quadratic functions are functions that have a degree of 2. So a quadratic function is a function that can be written when it's in standard form. It can be written as y equals ax squared plus bx plus c. So that 2, that power of 2, that degree of 2, when you see that, that's what should be making you think, okay, this is a quadratic function. So as long as a, the number in front of your x squared, isn't 0, and you still have that x squared value, then it's quadratic. So the graph of a quadratic function is in the shape of a parabola. And you guys probably have heard that term before. And that's that picture below here. So a parabola is a U-shaped function. So the parent function, that's right there below. That little bit of information there, it says f of x equals x squared. And remember, guys, that f of x is really just a y. So this is just saying the parent function is y equals x squared. That means if nothing is being multiplied, added, subtracted, divided by that function, nothing is altering it. It will start as that. But of course, it doesn't always just look like x squared. There's usually more numbers involved than just x, just one x squared. And it will alter it a little bit. But that would be what the parent function looks like. And that's what it shows you there right below that box. So, a parabola can be facing up or down. So if we look at that box to the left where it says maximum value, maximum value means that the vertex is at the top. It's maxed out, if you will. So the vertex y coordinate is going to be a max if a is less than 0. So if your a value is negative, your parabola is going to face down. And that point right up there at the top is going to be your max. So when do you have a min value, meaning you have a point at the bottom of your parabola? That's if your a is positive, and then you would have a point at the bottom. And that's going to be a min. And to this day, guys, I still draw them out because for whatever reason, I always think opposite. I think, oh, if it has a negative a value, it must have a min. But that's not the case. That negative a value makes it face down, giving it a top point or a max. So based off of your a, if it's positive or negative, that's going to determine if it's opening up or down, and then if you're going to have a max or min. So the other two items over here are the axis of symmetry and the vertex. So the axis of symmetry is the line that essentially divides or reflects your parabola. So it divides the parabola into two mirror images, cuts it in half. So if you tried to fold your parabola over that line, it should lay right on top of itself. And it always passes through the vertex. Which leads us down to that last box. What is the vertex? So the vertex is the single highest or lowest point. So we said it could be a max or min, but the vertex in your example problem is this point right here at the bottom of your parabola. So in this case, it's the lowest point of the parabola. The way you guys can find the x value of your vertex, meaning what value that axis of symmetry goes through, is by using this formula, x equals negative whatever your b value is divided by 2 times whatever your a value is. So it's essentially finding the average or the middle of your parabola. So that would be how you would find the x value. And you guys know if you have the x value, if you're trying to find the y value of that vertex, you just have to plug that value back in. So it's sort of a two-part process. If you're trying to find the vertex, use that formula to find x. Okay, substitute that x value in to get the y coordinate of your vertex. So your key concept box just sort of shows you some key ideas about what you're going to see by looking at the different parabolas. So it gives you guys one parabola that is facing up and one parabola that is facing down. Now, if you notice, the only difference between each equation on the left and right is this part right here, what your a value is. So it's showing you that on that left-hand side, for your parabola that's facing up, this a value has to be greater than 0. It must be positive. If it's facing down, then that a value must be negative. So the graph opens up if a is less than 0, and down, or I'm sorry, it opens up if a is greater than 0. I just said that. And it's going to open down if a is less than 0. And that a value is not just going to be important in this unit. Every unit we talk about functions and graphs is going to be important and tell you a lot about at least what your function should maybe look like. So how do we know if the graph is going to be narrower than the parent function y equals x squared? So it gives you guys this parent function as if nothing is being added or subtracted to it or multiplied or divided by it. So when does the graph become narrower than the original? So the graph is, it says narrower, it really means sort of skinnier. So it's going to be narrower if the absolute value of that leading coefficient, that a value, is less than 1. Because what's going to happen there is it's going to stretch it. Sort of like a rubber band. If you have a rubber band that's just relaxed, when you try to stretch it out, it gets skinnier. The same amount of rubber band is still there, but it gets thinner because it's stretching a further distance. So same idea goes here. If it's less than 1, it's going to be skinnier, narrower, stretched, and it's going to be wider if that a value is less than 1. So what that is saying, guys, if you have an a value that's a fraction, like 1/2, 1/3, 2/5, 5/7, if it's less than 1, it's going to squish it and make it wider, but if it's larger than 1, it's going to stretch it, make it skinnier, make it taller. So just more things that a value is telling you about your parabola. And then the last one is the axis of symmetry. And that is above there, so this is just sort of repeating. But the axis of symmetry goes through the x value, so it's at x equals whatever that value is that you find when you take your negative b value and divide it by 2 times your a value. So the axis of symmetry goes through the x value of your vertex. So if you've found the axis of symmetry, you know the x value of your vertex. If you've found the x value of your vertex, you know where the axis of symmetry is. So let's go ahead and try some examples. So for number 1, it says graph y equals negative 3x squared. So it wants us to compare the graph with y equals x squared. So it wants us to say, okay, based off of the parent function, what has now happened when we've multiplied x squared by negative 3? So first thing we're going to do, I'm just going to fill out my xy table so we can plot some points. So if we plug in negative 2, so y equals negative 3 times negative 2 squared. Anything squared is always positive, so positive 4 times negative 3 is negative 12, so we won't be able to graph that, but that's okay. Negative 1 squared will just be 1, so negative 3 times 1 is negative 3. 0 squared is 0, anything times 0 stays 0. Positive 1 squared will give us 1 still. 1 times negative 3 is negative 3. And 2 squared is 4. 4 times negative 3 is negative 12. So you might be thinking, why am I getting the same points? But that's good because a parabola is symmetric. So if it's going right down through the center, if you have negative 12 as a y value on the left side of your axis of symmetry, you should have negative 12 on the right side of your axis of symmetry as well. So let's go ahead and plot the points we can plot. So 0, 0, 1, negative 3, 1, negative 1, negative 3. And then we can't really plot 12, so I'm just going to draw it like so. So what has happened from the parent function to this function now by multiplying it by this negative 3? So I'm just going to put some bullet points here. So for y equals negative 3x squared, the negative made your parabola face down. And the 3 is greater than 1, so the parabola got stretched or more narrow. So that's all there is to it. So just by looking at that function, I know that when I see a is negative 3, and we can even write that as a note, a is negative 3. I know, okay, this should be facing down, and it should be a little skinnier than your parent function parabola. At the very bottom of your page, it talks about the concavity of a parabola. Concavity is just really a vocab word. And concavity talks about whether it concaves up or concaves down. So if you look at your examples, the one we did together, number 1 flips down because a is negative 3, and negative 3 is less than 0. So for problem 2, from above, it would concave up because your a is 1/4, and 1/4 is greater than 0. So a can tell you guys whether it's going to concave up or down and if it will be stretched or compressed. So you guys don't have to write this down, but if I give you the two examples, y equals negative 4x squared minus x plus 3, that negative 4 tells you guys that it will face down because it's negative. And the 4 tells you that it will be stretched or narrow because 4 is greater than 1. And remember, that's why we say the absolute value. So for your second example, 1/3 is positive, so this one should face up when you graph it, and the 1/3 tells you, okay, if 1/3 is smaller than 1, it's going to be compressed or fat or squished or wider, however you guys want to remember that. But because it's smaller than 1, it's going to get compressed and look wider. So that A value can tell you a lot about your parabola and what it will look like. AX squared plus BX plus C. And remember, A, B, and C are just number values. So for number 3, it asks us to do a little more than just simply graph and compare the function. It says graph y equals 2x squared plus 6x plus 3, but then it asks for what are your coefficients? How does it concave? What's the vertex? So the first thing let's do is find what our coefficients are. So if we're looking at this, 2x squared plus 6x plus 3, it's in standard form, ax squared plus bx plus c. It's not in standard form, guys, if it goes from x to x squared. The highest degree, that exponent of 2 has to be before the x value, which has a exponent of 1. So your coefficients here, A is going to be 2, B is 6, and C is 3. Okay, how does it concave? Well, if you're looking at A, 2 is your A, and 2 is greater than 0. It's positive, so it should concave up. But then it asks us to find the vertex. So this is where we have to find x first and then plug the x value of the vertex in to get the y value of that vertex. So if we're trying to find the vertex, let's do x equals negative b over 2a. So that's going to be negative our b value, which is 6, divided by 2 times a, which is 2. So we get negative 6/4, which reduces to negative 3/2. So to get y, we just plug it back in. So y equals 2 times negative 3/2 squared plus 6 times negative 3/2 plus 3. So you guys could type that into the calculator. You could do it in your head. I know that 3 squared is 9/4 times 2, and then plus 6 times negative 3/2 plus 3. So I would get this, oddly enough, to also be negative 3/2. So this situation is kind of weird because your x and y coordinate are the same, but that's okay. So your vertex will be at negative 3/2, comma, negative 3/2. So you guys can leave it as a fraction, you can leave it as decimals. 3/2 is the same thing as 1.5. So let's go left 1.5 and then down 1.5. So you're right in the middle of that box there. So your axis of symmetry, guys, goes through that x value. So your axis of symmetry is at x equals negative 3/2. Like I said before, if you have the x value of your vertex, you know where your axis of symmetry is. It just goes through that value. So your y-intercept, guys, is always when x is 0. You're finding y. So if you're trying to find this, all you have to do is plug in 0 everywhere you see an x. So y equals 2 times 0 squared plus 6 times 0 plus 3. So in this case, everything that multiplies by 0 goes away. That's why we like zeros. And we're left with 3. So 0, 3 is your y-intercept. Now it asks us to evaluate for one more x value. So I'm just going to plug in -2. So let's plug in -2 for x and get y. So y equals 2 times -2 squared plus 6 times -2 plus 3. -2 squared is 4 times 2 is 8. Okay, and then 6 times -2 is -12. So we have 8 plus -12, which is -4. -4 plus 3 is -1. So -2, -1. So it may not really look like much of a parabola, guys, but here's the nice thing about parabolas. That axis of symmetric. So I know that if I have that green point there of -2, 1, just to the other side of that, -1 has to be a point because that's symmetrical or equal distance from the axis of symmetry. If I have that blue dot of 0, 3, I know that the point 3, 3 must also be a point because it's equal distance from the axis of symmetry. So even if you only find 1 or 2 points, you actually have 2 or 4 because you can just mirror the couple of points that you found, if that makes sense. And then it looks more like a parabola, and then you guys can draw it. So go ahead, guys, try the couple that we did not do together and let me know if you need help. And I will help you guys also with finding the max and min values with the graphing calculator.